Look up. Every star you see in the night sky is a sun, most of them older than ours, many of them with planets. Some of those planets are in the right place for liquid water. Now zoom out. Our galaxy alone may hold billions of Earth-like worlds, and beyond that, hundreds of billions of other galaxies. If life is even moderately common, then the universe should be overflowing with it, with civilizations, with signals, with someone. And yet, silence. No radio messages, no star-sized engineering projects, no undeniable trace that anyone has ever been here before us. In 1950, over lunch at Los Alamos, physicist Enrico Fermi put his fork down and asked one question that has haunted science ever since. Where is everybody? The Fermi Paradox is the clash between two simple facts. On one side, the numbers strongly suggest the galaxy should be full of intelligent life. On the other side, the evidence is nothing, no signals, no visits, just silence. In 1961, astronomer Frank Drake wrote down a simple way to think about this. He broke the problem into steps. How many new stars are born in our galaxy? How many of those stars have planets? How many of those planets are in the right zone for liquid water? How often life actually starts? How often life becomes intelligent? How often intelligent species build technology that can be detected from far away? And finally, how long those civilizations keep broadcasting before they disappear? If you choose optimistic values for those steps, you end up with a Milky Way containing thousands of active civilizations right now. If you choose very pessimistic values, you can end up with just us. The paradox is that we don't know which it is. Because no matter what the calculation says, we still see the same thing when we point our telescopes at the sky. Silence. So either the way we're doing the math is wrong, or something out there, or something inside intelligent civilizations themselves, is stopping almost everyone from ever saying hello. Let's start with the part that isn't a guess. Astronomers now estimate there are roughly 100 to 400 billion stars in the Milky Way. Space telescopes like Kepler and TESS have shown that planets are normal, not rare. One recent analysis suggested that around half of all Sun-like stars may have at least one rocky planet in the habitable zone, where liquid water is possible. Another study estimated there could be up to 6 billion Earth-like planets in our galaxy alone. Now zoom out again. Hundreds of billions of galaxies in the observable universe, each with billions of stars, each potentially with Earth-like worlds. If we imagine that life arises on just 1% of habitable planets, and intelligent life on 1% of those, we still end up with a universe that should be full of civilizations. If even a tiny fraction of those civilizations survive long enough to become spacefaring, then over millions of years they could spread across large parts of the galaxy. The Milky Way is about 100,000 light-years across. Even at a small fraction of light speed, you could in theory cross it in tens of millions of years. The galaxy itself is over 10 billion years old. If advanced civilizations were common and expansionist, the galaxy should have been colonized many times over by now. And yet the sky is quiet. Let's start with the part that isn't a guess. Astronomers now estimate there are roughly 100 to 400 billion stars in the Milky Way. Space telescopes like Kepler and TESS have shown that planets are normal, not rare. One recent analysis suggested that around half of all Sun-like stars may have at least one rocky planet in the habitable zone, where liquid water is possible. Another study estimated there could be up to 6 billion Earth-like planets in our galaxy alone. Now zoom out again. Hundreds of billions of galaxies in the observable universe, each with billions of stars, each potentially with Earth-like worlds. If we imagine that life arises on just 1% of habitable planets, and intelligent life on 1% of those, we still end up with a universe that should be full of civilizations. If even a tiny fraction of those civilizations survive long enough to become spacefaring, then over millions of years they could spread across large parts of the galaxy. The Milky Way is about 100,000 light-years across. Even at a small fraction of light speed, you could in theory cross it in tens of millions of years. The galaxy itself is over 10 billion years old. If advanced civilizations were common and expansionist, the galaxy should have been colonized many times over by now. And yet the sky is quiet. Over the decades, scientists and philosophers have come up with hundreds of possible solutions to the Fermi Paradox. They fall into a few big families. They're out there, but we're looking wrong. Maybe intelligent life is common, but we're just not seeing it because, we've only been listening for about 60 to 70 years, which is nothing on cosmic timescales. We're tuned to the wrong frequencies or using primitive methods compared to what an advanced civilization would use. Their signals are short-lived, rare, or aimed somewhere else. Or maybe they communicate in ways that don't look like signals to us at all, using neutrinos, gravitational waves, or something we don't even have a word for yet. Comfort level: high. The universe is full. We're just toddlers with a walkie-talkie listening to the wrong channel. 2. They're out there, and they're hiding. Another family of answers says, they exist, they know we're here, and they're deliberately silent. Zoo hypothesis. Earth is like a nature preserve. We're being observed, not contacted, the way we might watch animals in a wildlife documentary without disturbing them. Planetarium. Simulation hypothesis. We're inside a constructed reality, curated so we don't see evidence of others. A kind of cosmic planetarium. Dark forest hypothesis. Popularized in science fiction, it suggests the universe is dangerous. Any civilization that advertises its location risks being destroyed, so the smart ones stay quiet. Comfort level drops quickly. Because in these scenarios, the silence isn't empty, it's intentional. The most unsettling family of answers is simpler. Maybe advanced civilizations are not common. Not because life can't start, but because almost nothing survives long enough to become truly visible on a galactic scale. This idea is called the Great Filter. Imagine a long timeline. Dead matter, simple chemistry, single-celled life, complex life, intelligence, technology, spacefaring, star-altering civilizations. Somewhere along this path, there is a step that is extremely difficult to pass. So difficult that almost everything fails. That step, wherever it is the Great Filter. If the Great Filter exists, then the big question is it behind us? Or ahead of us? Scenario 1. The filter is behind us. In this version, something in our past was incredibly unlikely. Maybe the jump from non-life to life, abiogenesis, is astronomically rare. Maybe the step from simple to complex cells almost never happens. Maybe the combination of a stable star, a protective magnetic field, plate tectonics, and just right chemistry is a cosmic lottery ticket. If that's true, then we are rare. Extraordinarily, unbelievably rare. The silence of the universe would not mean failure. It would mean that we are one of the few, or the only, civilization to have gotten this far. That is both lonely and hopeful. Lonely because we may never meet anyone else. Hopeful because the hardest part might already be over. Scenario 2. The filter is ahead of us. The darker possibility is that many civilizations reach our level, and then almost all of them hit something they can't get past. Maybe any species that invents nuclear weapons eventually uses them. Maybe uncontrolled climate change, AI misalignment, engineered pandemics, or something we haven't thought of yet reliably wipes out technological societies within a few centuries of industrialization. In that case, the silence is not a comforting emptiness. It is a graveyard. The galaxy might be full of ruins and extinct cultures that rose briefly, lit up their sky with radio waves and city lights, and then vanished before they could spread very far. In this scenario, we are not rare. We are early in the danger zone. Which leads to three famously blunt options some writers summarize this way. We're rare. We're first. Or we're fucked. There's another angle to the Fermi Paradox that's easy to miss. We often talk as if the challenge is purely physical or technological. Building starships, surviving supernovae, managing resources over millions of years. But a growing number of thinkers argue that the real bottleneck might be psychological and social. Civilizations don't just need advanced technology. They need to handle the side effects of advanced technology without destroying themselves. They need to coordinate globally, manage weapons capable of extinction, adapt to automation and AI without catastrophic social collapse, resist the temptation to freeze progress out of fear or accelerate it recklessly out of greed. A recent discussion of the Great Filter framed it this way. The same survival instincts that helped early humans can also make advanced civilizations afraid of transformative innovations, afraid of technologies that could render them obsolete, afraid of changes they can't control. If that's true, then many civilizations might get stuck, not wiped out by a cosmic disaster, but trapped by their own psychology, choosing safety over exploration until their window closes. In that picture, the Great Silence isn't just about physics, it's about minds. The Fermi Paradox feels like a question about aliens. But every serious answer to it is a question about us. When we ask, why isn't anyone else out there? We are really asking, what are we about to become? If the universe is empty because intelligent life is rare, then we might be one of the only chances consciousness has to understand itself on a cosmic scale. That implies a responsibility we almost never talk about. If the universe is quiet because most civilizations self-destruct, then every existential risk we face is not just a local problem. It is the test almost nobody passes. And if the universe is full of civilizations that are choosing to stay quiet, hiding, watching, or simply minding their own business, then the question becomes, would we be one of the loud ones? Or one of the cautious ones? Right now, we are broadcasting our existence in every direction at the speed of light. Radio, television, radar, internet leakage, planetary-scale city lights. For the first time in Earth's history, something here can be noticed from very far away. We don't know who, if anyone, is listening. We don't know what the right move is. Shout louder? Go dark? Keep pretending we're alone? The Fermi Paradox doesn't tell us the answer. It just holds up a mirror and asks, if the story of the universe is mostly silence, what do you want our part of it to sound like? We've just spent an episode asking a huge question. Why is the universe so quiet? Why does everything out there feel so empty and unknown? Next time we're going to talk about something much smaller and much stranger. Not distant galaxies, a face on the subway. You've met this person once in your life, or never at all. And yet when they walk past, something in your brain whispers, I know them. A stranger in a new city who feels like someone from your childhood. A street corner you're sure you've stood on before. A conversation that feels like a replay of something you can't quite remember. We call it déjà vu, déjà vu, jamais vu. Psychologists have been trying to pin it down for over a century. Is it a glitch in memory? A prediction error? A tiny sign that your brain is constantly simulating futures, and sometimes those simulations leak into the present. Why do unfamiliar faces and places sometimes feel more real than your actual memories? And what does that say about how much of your life is being lived in reality, and how much is being lived in your head? That is next.